disclaimer. Okay, you really can't see anything in this thing. All right. This talk is an opportunity for me to geek out in front of all of you, showing you lots of sci-fi things. Heavily based on written sci-fi, not so much TV and movies, and specifically relying on cover art from lots of the sci-fi cult magazines that I'll talk about in a little bit. But so just for some context. Also, I know there's a lot of really awesome sci-fi, particularly from the UK, as Rachel I'm sure would point out, and also Soviet and Russian sci-fi and other languages and stuff that's really cool. I'm going to stick mostly with American stuff because that's kind of the birthplace of where science fiction kind of exploded, and it's what I know best. So let's see if we can get this to go. There we go. All right, so to travel to space, step one, we should leave Earth. Anybody know who this guy is? Okay, so we've got Isaac Newton. The apocryphal story is that he was sitting in a field one day and he was like, oh, some apples fall on my head from a tree that I was sitting under just thinking. What if the reason that those apples are falling is the same as the reason that the moon is up in the sky all the time? There's a force pulling the apples toward the Earth. What if there's also a force that's pulling the moon toward the Earth, and that's actually the same thing? That was, I mean, obviously Newton did a ton of really revolutionary stuff in physics and astronomy, but this was his universal law of gravitation. And so what that's really saying is, so this is his, I don't know if he actually drew it, but from his book, The Publication of the System of the World, he postulated that if you had a mountain tall enough on the Earth, and you shot things off of it with increasing speed, that eventually you could get into orbit. So you could have a situation like this. So if you shoot it not too fast, it falls down. You shoot it a little faster, it gets a little farther. Eventually you can shoot it fast enough that it will actually orbit all the way around the world. And so that's how you get into space. So this is from, you know, like the 1700s. This is the really the first time that people made serious attempts at thinking about like how does motion in space relate to what I see here in my everyday on Earth? And so enter science fiction, where people are like, oh, okay, so let's shoot people out of a cannon. That's how that works then. Awesome. So Jules Verne writes a story about shooting men out of a cannon, and they go to the moon, etc. And George Méliès, who is, if you've seen the movie Hugo, it's all about his work, but he made the first science fiction film in 1902, and so this is a trip to the moon. I'm going to play you a short clip here so you can see them getting shot out of their cannon and traveling to the moon. Oh no. Is there some special button I need to push to make it play? There we go. So they all line up, they're very excited, toot the horns, show the flag. Yay! So this is still one of the most iconographic. It's an iconic shot from movie history. The cannon, the bullet from the cannon landing and hitting the man in the moon. So the scientists all pop out, they're on the moon, it's so exciting. They don't need any of that fancy spacesuit stuff or whatever, they're just on the moon and it's super cool. So this okay, is 1902. This is the state of kind of what we thought maybe the future and space travel, what it would mean to leave the Earth, which was something that wasn't really fleshed out a whole lot before. So then, okay, digression for just a second. Science fiction is a genre. Again, I'm focusing mostly on written science fiction, but most movie and TV show science fiction is derived from written science fiction, so the history is the birthplace of both. So most people agree that Mary Shelley's Frankenstein was the first science fiction novel ever written, from the mid-1800s. From there, you have a couple of people like H.G. Wells and Jules Verne who Really, and several others who used sci-fi as mostly a vehicle for satire. It wasn't quite what we know it to be today, where it was like actually postulating what could the future be like. It was, here's a contrived scenario that's different from your everyday life, and I can highlight some societal concern by the differences from that situation to what we're used to. And so there's a lot of really interesting and really good sci-fi there, but mostly it was attempts at satire. And then from there, you kind of get into, you know, the Great War and the early 1900s, and you know, radar explodes during World War I. Technophilia kind of really took off, and people were starting to be really, really excited about the possibilities of what science could do for the everyday person. And so that's kind of where the explosion of science fiction stories came from. And so that really started with these magazines, the pulp magazines, which were kind of published in sort of comic book form in terms of like the size of the publication and the types of places you would see them sold and stuff. And so these exploded. So the first was Amazing Stories in 1926 here, and they republished a lot of things from Jules Verne and H.G. Wells because Hugo Gernsback, the editor of the magazine, thought, you know, these are the foundations of this genre that basically I'm going to single-handedly force into existence as a like real thing. And so if you know anything about science fiction, written science fiction, the Hugo Awards, I guess they give some for TVs and things too, they're named after Hugo Gernsback, who is the editor of this magazine, who kind of like brought science fiction to the masses. Just so you know, the Internet Speculative Fiction Database is a place where I found basically almost all of the images from here on out are cover art from many, many of these different magazines and publications. So the magazines are where pretty much every classic sci-fi author you've ever heard of started. Isaac Asimov, Arthur C. Clarke, Ray Bradbury, Robert Heinlein, all of them got their start in these magazines. And so it wasn't until the 50s and 60s when mass paperback publications started to come out that people actually started really writing sci-fi novels. Before that, they were just serials in these magazines that later were anthologized. So, okay, enough of science fiction as how it's run as a genre. So here, people are taking that idea of Isaac Newton and like, okay, shooting people into space, the Jules Verne canon, get somebody to the moon. So then you start to see these depictions of, things that are rockets, but basically just bullets, right? And so then you evolve a little bit, oh, Zeppelins, let's have blimps, but have fins on them, and it's super spacey and sci-fi and cool. And also, you start to see a lot of ways that are very similar to nautical themes, like, okay, well, let's have a ship, but it's in space, so it's a spaceship. And so that's kind of what this looks like, right? It's an ocean liner, but it happens to be in space and have a rocket on it. And so that's kind of where a lot of people went with the idea, and most of this science fiction that was written at the time in like the 20s and 30s was just like adventure stories that happened to be set on some other planet. It didn't have to be anything related to, even remotely, to what could be physically plausible. So then in steps John W. Campbell Jr. as the editor of one of the premier magazines at the time, Astounding, which is right here. John Campbell steps in and says to all these writers, including the young Isaac Asimov and the young Heinlein and the young Arthur C. Clarke, that stuff's not going to fly anymore. I want you guys to write stuff that could actually really maybe happen. You need to have stories that are actually written well, because that's one of the things that the genre had fought against, is that that people would churn out these adventure stories so quickly and so much that the writing was actually quite poor, and science fiction still kind of battles this perception of not being real literature. And so when it's, critics do reviews of things and movies as well, they're considered, popcorn, mass consumption stuff. They're not real art. And that's kind of born out of the way that the genre started, but it started to be less true under his editorship. And so now you start having authors that are forced to write about things that maybe could actually be real, and still were extrapolated very, very far in the future, and so were maybe more or less plausible, but still grounded in reality. So now we're gonna have spaceships that look like things that could actually fly, right? These, they're aerodynamic. They actually, this one you can see that it's arcing, so it's representing the fact that the Earth is turning as it's shooting up in a straight line into space. And so you can see that the trail is actually being arced away from the path of the spaceship. Another one of the things that that kind of realism is, well, to go back for a second, so there were spaceships like this. I don't know if you guys can see it real well. This is a one-man spaceship, right? And the manned section, it's basically the size of a fighter jet, but with a rocket on the back. And so that thing would never get you into space. It turns out you need a lot of propellant to get things into space. However much mass you add to the payload of what you're launching, it's really hard to get off of the Earth, and so you need a whole lot of fuel. And so this is not big enough. You need something more like this, where now you have like that little section right there is where the people are, and all of the rest of this is rocket fuel. And so you start to get those more realistic depictions. And then this is also, that's the doorway, the hatch over there. And these are the people out in front. So you kind of get that depth perception of like, oh, this is actually a really big thing. And it's hard to fly through space and to get off the Earth, so maybe we need lots of rockets. So that's why there's the extra ones on there. And so then, oh, well, what happens when you predict the future and then it actually starts to happen? That's not the future anymore. The Russians launched Sputnik into space in 1958, and the whole sci-fi community was like, oh, what? That, okay. I mean, lots of people had thought about things much farther ahead than that, but I think collectively the science fiction community was not prepared for humanity to advance as quickly as we did during the 50s and 60s. So Sputnik is launched, and the US is like, crap, let's put stuff in space too. And so let's launch Mercury, which is the first single human spacecraft. And you can see here, so the way that this little part right there is where the person is, and all the rest of this is rocket. So it's again getting to that mass to propellant ratio. So you get multi-stage rockets here where, this is made so that this bottom half shoots you up part of the way, and then it falls off so you don't have to carry that empty weight around. And then this part starts shooting and pushes you up even farther, and then you drop that because you still don't want to carry any extra weight than you have to. And then this is the only bit that actually makes it into space. So then, okay, now, Gemini, we got 2 people into space. Woo! Apollo, we got 3 people into space. Even better, and let's put them around the moon, and that's where all the moon landings happened, were with the Apollo rockets. And you can see the progression from 1 person to the amount of rocket you have to launch 3 people is substantially more, because it's really, really hard to put mass up into space. You need a lot of energy to do that. So then this real life progression happened, and we get to the space shuttle. There we go, which was launching crews of 6 up into space. And all of this happened really fast, and the sci-fi genre, like all of the writers were like, okay, well, where is this gonna keep going? This is a really quick progression. I bet it's just gonna continue. And of course, there's a lot of shocking stories from like the 80s of like, but what's happening? Why isn't there more, why aren't we doing more other things? Come on guys, let's launch more stuff into space. But you start to see the stories having more realistic portrayals from the cover art here. This is a multi-stage rocket that looks a whole lot like the ones we were just looking at. And then you start to see, the shock wave here, and the underside of this looks a lot like the undersides of the space capsules when they would come in. As you push through the atmosphere, it basically, the friction of just the air rubbing against the capsule makes it really, really hot, and they just put a surface on it that's meant to burn away. And so you can kind of see that that's what the design for this one is right there. And then you see depictions like this, where this is actually quite a lot what the space shuttle looks like. It can go up into space, and then the cargo bay doors open, and there's like, satellites or whatever, your Hubble telescope, whatever you want to put up. and you stick it in there, and then you can release it and put it into orbit and do whatever you want. So, you know, now we're starting to look like, okay, science fiction is just depicting real life. Well, that's boring, and that's not the point. So what do we need to do to push even farther into the future? So then we have things like, let's put a lot of rockets on it. It's real big, so it's got a lot of rockets. Or let's just, you know, make it really huge, but you know, now we've got, so this is the little door where this thing came from, and this seats like lots of, this is kind of your, looks a lot like your Star Trek shuttle or something launching from the main spaceship. But these are now really, really enormous rocket ships. They're not anything like the early ones. They understand that in order to get something up there into space and to have people in it, it needs to be actually huge. Okay, so if we're gonna make something actually huge, let's put a ton of rockets on the back of it. And I don't know if you guys are familiar with Arthur C. Clarke's Rendezvous with Rama, but there's the idea of, you know, if you're just up in space, you're floating around, and you're, if you see, you know, videos of astronauts on the space station and stuff, there's the weightlessness effect that they worry about. But if you're in space for a long time, you don't actually want that. You want to feel like you're on gravity and can walk. You don't want to have to fly around and bump off of surfaces to get anywhere and stuff. And so what if you put them in a cylinder and it just spins? Now you have centripetal force that will keep people basically walking along the edges of this circle, and that'll be the floor. So then, okay, there we go. I don't know if you guys can see this kind of behind me, but then you think about the fact that, okay, if I have a really big ship with a lot of really big rockets on it, you don't necessarily want all that fire and stuff where the people are. Seems like not a great idea. So then you start seeing this design of where, you know, the habitable spaces will be up here, and there's a long stalk, and then you have the actual propulsion unit on the end there. Similar to this. So you can do that with just regular rockets, or you can try to have an actual fusion chamber and then running the propellant out through the length of the rocket ship. There's actually a really cool design, the Prometheus spaceship design, where it's both an attempt at disarmament and a way of propelling spaceships. You just take all of the nuclear warheads that we already have, and you just let go of them behind your spaceship and set them off. And if you have a nice flat plate on the back of your spaceship, the boom from the actual nuclear explosion just pushes you. So that's kind of a cool, oh, sorry, there we go. So there's a lot of really cool stories actually that do those two things at once. We're gonna explore space, and also we're gonna disarm the world, and everybody lives in peace. I like science fiction utopias, so I'm fond of those. There's also, you can have this idea where, what about something, so, sorry this is so dense, but, so let's focus on this one right here. It turns out, you guys, we heard a little bit about some of Einstein's work earlier today, but what's Einstein's most famous equation? E equals mc squared, right? So that means that mass and energy are related to each other, right? So the sun puts out lots of energy, right? The light that the sun puts out. It turns out that that also has some properties kind of like mass, where when it bumps into something, it has momentum and it can transfer energy to the things that it bumps into. So this is called radiation pressure. So what if we had something called a solar sail, where literally you're just being pushed along by sunlight? It's a very slow way to travel, but it's dependable. The sun's gonna be there for as long as your trip is happening. So, I mean, barring crazy catastrophic sci-fi things, but so it's a dependable way to get around. Another really cool idea is represented with these two guys here. So you see the funnel on the end of this, and this one has a funnel too. So I don't need propellant. I don't need to bring anything along with me. Once I'm in space, what if once I'm just moving, I just suck up hydrogen along the way, right? There's hydrogen all throughout space. It's not a perfect vacuum. There's lots of stuff. You have to travel a long way to gather very much of it, but you can gather it. So you can use something like magnetic fields here, or even just like a big scoop or something to actually gather in this gas as you're moving through the gas in the solar system and elsewhere, and just use that as your rocket fuel, because rocket fuel is just hydrogen and oxygen anyway. And so then why have to worry about launching it up there in the first place? Just get it once you're up there. Or, you know, you can have a hybrid model where this is propelled by a rocket, but it also has solar panels there. So, you know, once you're up there, then your operating power can be drawn from the sunlight that you're already receiving anyway. So there's lots of really cool ideas about like how to get around and how, once you're up in space, what you can do once you're there. This is, again, the real world is kind of starting to catch up with us. People are actually trying private attempts to launch people into space. So this, anybody know what this is? There's lots of mumbling. Nobody's bold enough to say it out loud. Yeah, so this is Spaceship One. So this is Virgin Galactic's attempt to launch people into space. So you just have a plane that flies up really high, and then this little guy detaches and has a rocket, and then shoots up into space. So you get the plane to get you pretty high off the ground. You don't need rocket fuel to get you all the way up there, and then the rocket just takes you the last little bit. And then what about this guy? Anybody recognize that? Yeah, so this is SpaceX, right? The company's getting the reusable booster rockets to land on their drone-controlled platform here in the ocean. And so, again, the real world is starting to catch up with science fiction and do some of those things themselves. So, oh crap, this did not come out very nicely. All of that's based on reality, but most of science fiction, or not most, but a lot of science fiction, there were a couple of things that got integrated into the field of science fiction before John W. Campbell came along and was like, stop it guys, it needs to be real. And some of those that are just built in and part of the genre are faster than light travel and time travel. And so faster than light travel is what we're depicting here. So I guess you can't really see this thing in the back there. But so you can have either hyperspace, or you can have jumps like in Battlestar Galactica, where you're literally just displacing ships from one point in space to a different point in space without traveling through anything. Or you can have Starship Enterprise going into warp drive, there we go, traveling faster than the speed of light. This thing back here that you can't really see is depicting something traveling through wormholes, which is another one of those, like, it'd be cool if it worked, but we don't really have any actual basis of thinking that it's physically possible, but it's a neat idea and it's built into the genre of sci-fi, and so it's fun to think about and have as a mechanism in our stories and movies and shows and stuff. So, okay, so we managed to get out there. Oh, now what do we do? Now let's live in space. What is that even like? So the first couple slides here I want to show you are what spacesuits were like. So this one, you can kind of see that nautical theme coming again. They're very rigid. They have the accordion knees and elbows, kind of like early prototypes of underwater diving suits. This is one of my favorite things I've ever seen. They're tank skates. I don't know where they're supposed to be going or whatever, but it's just a beautiful depiction of what science fiction can do. You also see this is kind of like a hazmat suit look, right? It's loose fitting, it's kind of baggy, it's got the solid clear helmet without, I guess this guy has the fishbowl helmets. Then they realized you don't actually want to be surrounded by glass, and that back part you can't see anything anyway, so maybe it's safer to actually have it be solid, not glass. So, so then you get more typical spacesuits, which look like what we're used to. They realized things like, so it's cold in space. so we need insulation, so it's nice and thick for that. And also, it's a vacuum in space. Not a perfect vacuum, we talked about before, but you actually have to regulate the pressure on your skin. If your skin is exposed to a perfect vacuum, it doesn't like that, it's not good. So you actually need something to push in on your body and provide pressure since there isn't any air pressure or anything around you. And so, there we go. So this is a more realistic depiction, but then these are kind of starting to get to look like what we know of as spacesuits, right? With just simple little oxygen tanks on the back and whatever, but they're kind of form-fitting, but they're starting to kind of get into that right ballpark of like, this is what you would actually need to be in space. So then what about space stations? Where would you live if you want to get there? So this is actually a depiction of Skylab 1, which was the first space station that the US and Russia jointly tried to put into space. They did, but it's not there anymore. And so, but once you realize you can start putting things into space, you're not constrained by aerodynamics, right? If you start building stuff up there and it's just gonna be in space all the time, it doesn't need to be any particular shape, really. So let's just make it be whatever shape we want. We can just make it be like cities in space, like it's just basically a building just sitting in space. Or we can make it be any old whatever shape with bubbles off the side and whatever. I actually thought this one was really cool. So this is about a story called Sunstat. And so the back of this, the hexagon you see there is like a bunch of solar panels that absorb light from the sun so they can do measurements and things. And then this, if you can tell what it is, it's a bunch of blades that stick out and they radiate the excess heat away. You can imagine if you're intentionally trying to absorb a lot of energy from the sun, your space station would get very hot. And so this is basically a large set of fins to radiate that extra heat out so that they have operating power and can analyze the sun's energy in all the ways they want to, but they can disperse that extra energy and not burn up, which is nice. But again, like we mentioned before, you don't want to just be floating around indefinitely there. If you're going to live in space, it's actually pretty good to have gravity. You can get a lot of muscle atrophy and your digestive system doesn't work as well. And there's lots of reasons that you don't want to live in zero G. And so then you can start seeing these structures like this built, which are rings, circles that can spin, and then the centripetal force of them spinning will push people along the outer walls to be the floor. So you can imagine people walking along the edge of this and it's one big long track. Okay, well we could do that, but if we're gonna build things that are gonna rotate anyway, we could build big spheres. And it kind of, from an engineering standpoint, makes a lot of sense because then you don't have edges to worry about as much, and it's actually better at keeping in the gas pressure, and because obviously you want to have air and stuff in there if you're going to live there. So it's actually mechanically easier to do something like a sphere than it is to do something like a cylinder here. Or you could combine both, right? You could have the cylinder around the outside, the ring, and then you can have the sphere on the inside where you do intentionally have a zero G area for different things like experiments and recreation and things like that. How are we doing? Okay. So we can travel through the solar system. I'm going to flip through these real fast then. So, first place we can go is the moon, and it can look lots of different ways. You can have domes. You can take your family on vacation there. It turns out actually it's better to not have domes because then you can have like explosions from all the air escape. Tunnels are probably a better solution. You can go out to Venus, which used to be thought of as like exotic forests and everything, rainy, covered in clouds, and then the Soviet lander, can't see those at all. It's basically hot and will kill you. And so thanks for ruining our fun. We're not going to go there. We could go to Mars, which has lots of different depictions. Again, that optimistic, oh, we're growing so fast. We're going to go into space like so soon. We're going to have space stations and people on Mars in 1995. The asteroid belt had lots of Thoughts of mining was the idea. I love this because it's basically Rosie the Riveter in space. Mercury, lava falls, it's real hot there. So lots of depictions of people just trying not to burn up from the sun. Moons of Jupiter, just lots of really pretty pictures of what it would be like to live there. Moons of Saturn, ditto. And next step is, all right, let's go. Done.
Questions for MC Warp Factor 9. Straight back here on the floor. Yes, you.
Yep. Science fiction that's technically accurate, and I missed that last bit. Oh, the book, The Martian. Yeah. Yeah, absolutely. That's probably not a good idea. You need to go back. I can't move. I'm just tethered. Come grab him. Come grab him. Yeah, so there are actually quite a few more depictions of science fiction that are more scientifically accurate and what it would actually be like. I specifically focused on things that were like, what's beyond? What's over the next hill? What sorts of things will that be like? But there's my favorite description of things like The Martian or the movie Apollo 13, things like that. It's an astronaut procedural. Like a cop procedural or a medical procedural, but it's an astronaut procedural.
All right, another question. Do we have one upstairs?
Anybody else? Right.
All right here in the middle here.
The classic era of sci-fi, the 40s and 50s, that they completely mispredicted the future. And they figured that by our time period, the predominant technology would be rocket. Instead, it's computer science.
Right.
You think over the longer term that that's going to correct itself, or?
Well, I mean, I think it definitely already. Yeah. Sorry. He's pointing out that in the 40s and 50s, people were thinking that the predominant technology and advances would be in rocketry and spaceflight and things like that because they were seeing so much change in that at the time. But actually, the biggest change that's more recent that's been predominating our lives is computers and things like that. I think that even actually, if you read, Isaac Asimov's Foundation series. The early ones talk about these, room-sized computers and things like that, but because he wrote that over the course of decades, the later stories kind of self-correct and brush aside those big, huge computers that don't make any sense because that's not how computers work anymore. And so, I think sci-fi is always trying to figure out what the next big thing is, but there's no way to know, and so they make hundreds and hundreds of predictions, and some small subset of those end up being right? One of the biggest fields I would say that's come into play is AI and virtual reality and things like that are just on the verge of starting to look like those might be real things. So, I mean, there's things that we call AI and there's things that we call virtual reality, but none of it currently looks like what science fiction told us that would look like yet. So I think that's one of the areas that we're currently about to overtake those predictions. Yeah.
One more question for MC Warp Factor. Come on, nobody upstairs? I'm leaning at you. Pointing? All right. Somebody upstairs is pointing to you, sir, down there.
Okay. I have not, so Kim Stanley Robinson is probably my favorite author. And yeah, so speaking of, so the first question mentioned really accurate science fiction that really depicts what it would be like to explore space and be in space. And I think Kim Stanley Robinson is absolutely one of the best people doing that right now. And he's one of my favorite authors who was actually just at UT a couple of months ago and read an excerpt from his book and gave a talk and stuff. But his Mars trilogy, which I showed one picture of there, it does a great job of explaining like what all the actual difficulties are and everything. I love him so much that I ration how fast I read his stuff, so I have it on my bookshelf, but I haven't read it yet because I like to space him out.
All right, let's thank MC Warp Factor 9.